crazy how many events we've had, and everyone just every day just on-chain gaming, on-chain gaming, on-chain gaming. In the last 6 months, like over the last year, it's insane how many people have come into the ecosystem. I'm Tarrence. I've been involved in the space for about 2.5 to 3 years now. My journey started with Dope Wars that we released a few years ago and started building a fully on-chain game on top of Starknet, and that evolved into what is today Cartridge and Dojo. So I'm going to share a little bit about, I wonder if I can get this away. I'm going to share a little bit of an update about Dojo. It's mostly going to be technical. I think like for you guys, if you aren't familiar with Dojo, I'll give you a little bit of an introduction into the toolchain and the technologies that we're developing. And if you are, then maybe I'll give you a little bit of insight into like the roadmap and the things that you can expect over the next few months. Cool. So this is Dojo in a nutshell. Dojo is an on-chain gaming framework for defining provable applications that you can prove and verify on-chain with the goal of enabling this ambitious idea of autonomous worlds. There's a few different components that are part of the stack. You have that are identified with some of these illustrations here, and we'll talk about them. And then a bunch of games in the ecosystem that are started to develop on top of the Dojo toolchain. So I'm sure you're all quite familiar with the idea of autonomous worlds since you're at this very niche event. But high level, the idea is we want to put the entire logic and state of these virtual realities entirely on-chain, either through execution directly on a blockchain or potentially through provability and verifiability of the current state of the world. And Dojo is a framework to enable that, to enable worlds that are natively extensible, composable, and persistent. They can live forever and inherit the affordances of the blockchain. Today we have a bunch of teams building inside of the Dojo ecosystem. It's been really incredible over the last 6 months or so just to see all these new teams spawn up. I mean, one of our goals with Dojo has been just to compress the development cycle to allow people to ship games faster, and we've started to see that a lot of teams building really high quality games in a very short amount of time, taking advantage of the shared infrastructure of the blockchain, the toolchain that we built with Dojo to abstract a lot of the complexities of shipping these experiences on chain. And the quality of some of the new games, I think, is a testament to the progress that we've made in that regard. So today we have around 20 studios focused on building games full-time on top of Dojo. We have about 26 games across those studios. A lot of studios focusing on 1 or 2 different games or experiments. I think for us, it's really exciting to see that. We want just a lot of experimentation, people trying different things, trying to figure out what works, what are the unique affordances of the blockchain that can be integrated into these games and can solve some of the struggles that people have in the traditional gaming industry or demonstrate some of these capabilities that are uniquely enabled by the blockchain. And one of the exciting things in the ecosystem is we've started to unlock a lot of capital for these teams building on top of the Dojo ecosystem. So through support from different foundations of underlying protocols, like the Starknet Foundation and Celestia and stuff, providing grants, but also outside capital from now, venture capital, investors committing to teams building on top of this stack. So I'm going to talk through a little bit of the tool chain. It's composed of a few different components. We have the world, which is the provable logic of the world, of your game or your application. We have Sozo, which is a tool chain that manages the deployment life cycles of your smart contracts and the world state on chain. Katana, which is the execution, it's a sequencer and is kind of the execution layer for the Dojo ecosystem. Tori, which is an automatic indexer. I'll talk a little bit more about that. And Saya, which manages settlement, and a few other components that I'll get to later in the talk. So the world is the representation, the provable part of your application. It contains the logic and the models and the access control layer for how you can interact with this. It's what enables this native extensibility and composability. It's implemented with Cairo. If you're not familiar with Cairo, it's a domain-specific language focused on provability as a first principle. So efficient provability. It's by far the most efficiently provable language today, and it's developed by the Starkware team that invented Starks. So we've made a relatively large bet on this language as the way to bring these experiences on chain. So the world representation, there's a bunch of new things that we're introducing to it. It's really starting to stabilize. We have Dojo 1.0 coming out in the next couple of weeks. The big unlock is namespaces, is something that a lot of the developers have been interested in introducing to Dojo, which is something that will land in Dojo 1.0, and it just allows more easily extensibility and permission control inside of the world. We have new storage layouts that we're shipping, which allows more efficient storage of and packing of information on chain and supporting all the expressive types that Cairo supports. And then a lot of stability and performance improvements of the core implementation of the world. Like really at the end of the day, the world and the on-chain component, like this framework is ideally supposed to be like a zero-cost abstraction on top of Cairo. And it's quite simple, and most of the complexity of the toolchain is actually in the frameworks that surround it. So Sozo is a command line tool that basically helps you manage the life cycle of your smart contracts. If you've ever been developing smart contracts, you often have to write a bunch of scripts to figure out like when to deploy contracts, when to declare them, how to configure them with access control and stuff like this. Sozo allows you to do this in a declarative way, and it will automatically manage the life cycle of things and help you, set access control parameters around your smart contracts, compile everything, and to deploy it on chain in a declarative way that makes it very easily reproducible across environments, and will manage all that stuff for you. It's quite a powerful tool. And so we have manifests that we just landed in Sozo. So manifests are similar to if you ever use like Kubernetes manifests of how you define declaratively like infrastructure inside of Kubernetes. It looks very similar to that. You can just declaratively define like the smart contracts and the models, and a lot of this is already generated for you, and you can overload it with like parameters like constructor data or access control information. That enables some interesting use cases that we're going to ship later this year. We have controller support natively in Dojo with Sozo right now. So controller is a wallet that we've developed that uses WebAuthn and session keys, and it's an embedded wallet that we've integrated across the ecosystem. So like typically in a blockchain development context, you're using like something different when you're developing from when you're deploying into production. And we wanted to bridge that gap and unify the experience. So now you have your controller that I'll talk about it a little bit more in a little bit across this entire experience. So it's the same unified experience. You never have to worry about like funding accounts. You never have to worry about like protecting keys. Like your keys are stored in the secure enclave on your device. And it's portable across like the entire development lifecycle and the ecosystem. And then migration scripts is something that we're going to be adding to Sozo sometime later this year. So Katana is the StarkNet sequencer that we've developed that is focused on extensibility and performance. It's designed to execute on-chain games. And so we're starting to introduce like native functionality into Katana specifically for the type of architecture that we're building for scaling these types of experiences on-chain. It supports both running like as a persistent rollup, similar to like a layer 2 today, or it could be a layer 3, or as an ephemeral rollup that exists just for the duration, the execution of a particular session, like a round of a game or a dungeon crawl or something like that. This is kind of a high-level idea of the concept that we're going for with the execution sharding architecture that we're developing. So you have like some underlying blockchain. Like blockchains are just like anytime you're trying to deploy into a shared execution context, you're entering like basically like a zero-sum resource contention environment, and you're always going to be kind of affected by what other people are doing in that execution environment. And most of the time with games, you're like a lot of the interactions start to get priced out by more valuable transactions, like financialized transactions. We see this on Ethereum, where everything's being crowded out by DeFi activity, and the same thing will happen, in my opinion, in basically any shared execution environment. And so the goal with what we're building with Katana and execution sharding is this ability to fork some underlying network to have a dedicated execution context. And inside of that execution context, you have a lot stronger guarantees around the performance. So you can, for example, deploy it close to your users, have very low latency. You can have strong guarantees around like the cost of computation, because you're not bidding up on prices. You're just paying for resource usage. And you also have this unique affordance enabled by zero-knowledge proof, so you have like abundant access to state within this execution context. You don't accumulate historical state and have state bloat issues that like shared chains have. And so inside of this execution shard, you can run very immersive applications, efficiently prove them, and then settle them back on chain. And you can have a very small footprint that is the initialization, for example, of a dungeon run. It's like, what are the items that you're bringing into this dungeon run? And then at the end of the run, you can have a very small like finalization footprint, which is just like, okay, what's the outcome of the dungeon run? Like, what are the items that were unlocked? Like the health of the players or whatever. At the end of it, and you settle it on chain, and everything, all the history in between is compressed into just those two different state diffs. You don't have to store it perpetually forever. It's one of the unique affordances of using ZK versus other approaches for rollups. So with Katana, we have a few different things that we're working on. One is we just landed a new VRF implementation that's really cheap. Previously, VRFs on StarkNet were using cryptography that's not Stark friendly. So we implemented a native version of the IETF VRF specification with Poseidon and the Stark curve, which just allows us to have verified random numbers with like several orders of magnitude cheaper than the existing approach. So that's an example of gaming native functionality that we're starting to land into the sequencer. We're implementing a hypervisor, which allows Katana to basically concurrently schedule a bunch of different execution shards in a single instance, so you can more effectively utilize the hardware that the Katana instance is running on and parallelize across like a bunch of different games running concurrently. And then we're introducing support for running Katana in trusted execution environments, things like the secure enclave. It provides some interesting affordances for on-chain games. If you want to have a centralized sequencer, you can provide much stronger guarantees to your user through running the sequencer inside of the secure enclave. For example, you can provide end-to-end encryption of like the transactions that you're sending to it, which removes some of the MEV vectors, and you can also safely custody private keys and stuff that are necessary if you want the sequencer to be able to sign different things, like for example, in the example of generating VRFs. This is quite important. And I think it's an interesting approach for on-chain games, like given like the security requirements of what we're building. Tori is the automatic indexer and kind of the peer-to-peer node inside of the Dojo ecosystem. And so the architecture that we're going towards is, like I mentioned, with centralized sequencing for performance reasons. And the goal of Tori is essentially that everyone can run Tori nodes that hold the sequencer accountable, right? Like we already know that the sequencer can commit like an invalid state transition because it's using zero-knowledge proofs to attest to the correctness of the computation. But there needs to be good, easy, simple ways for players to verify all this information. And there's a few different components of that I'll touch on in a second. One of the other cool things that we're going to focus on in the next few months, we have this implemented inside of Tori today, but it hasn't been like well demonstrated and adopted by the ecosystem yet. Like we have these different levels of state that exist inside of Tori. So you have like on-chain state, which is obviously the hardest state. It's the most robust. It has the strongest security properties, and it can be mutated on state, and that is exposed through the Tori instance. We basically index your models and automatically generate this GraphQL gRPC API based on that typed information. We also have event streams where you can write from on-chain, and it's exposed through like a unified interface through Tori, which I think is quite powerful. Basically, like you can query entities that have different state and the properties of that state can be different. They can live on different layers of like this kind of abstraction. So you can get like on-chain state alongside these event stream states, but also off-chain state where you can just sign messages. You can sign like bundles of information defined by schemas or the models that are stored on-chain, and then you can publish them peer-to-peer through the Tori instance to other people that are communicating with it. And then you can, obviously check that the integrity of it through the signature, and then it can be queried again like through this unified interface through gRPC. So the things that we're working on with Tori, one is the dynamic subscription clause, which is going to be a powerful unlock in just like allowing people to dynamically load the world state more efficiently, particularly for the initialization of the games. So that's something we merged recently, and we're starting to see a lot more challenges with the old approach, just as more and more people are interacting with these games. We don't want games to get slower as more and more people play them. So this is a solution to that. The off-chain messaging stuff that I mentioned, I mean, this has been there for a few months, but we're just kind of like communicating a little bit more about it now. And then the verifiability is something that we're focused on this second half of this year, which is basically with the goal of enabling sovereign rollups, so rollups that don't necessarily settle to a chain, that just all the participants inside of this gaming ecosystem do the verification themselves. So you have the sequencer generating zero-knowledge proofs, and you have all the players verifying those proofs and verifying like the data availability with something like Celestia, and then if it's operating inside of a trusted execution environment, like verifying the attestations from that, and basically building their own confidence in the current state of the world and the logic that's being executed. So we're going to be shipping a bunch of stuff in that dimension the second half of this year. Saya is a settlement orchestrator, so we have with Dojo provable games applications. They can live anywhere. You can prove the computation, and then you can settle them wherever you want. Like right now, our focus is on settlement on StarkNet and the sovereign rollup architecture that I mentioned, but there's really a lot of opportunities to integrate this with a lot of different ecosystems and to build like this type of fractal scaling architecture where you can essentially have some base layer like Ethereum that provides the security. You can have like some global execution context like StarkNet that provides like the economic layer of your game. And then you can have like execution shards or roll-ups on top of that service like particular geographies or some subset of your player base. So in this case, you could have like an EU shard and a US shard, and then you can further shard that into like, for example, instance shards for like a particular dungeon run. And then eventually even do client-side proving at the player level. And so Saya is responsible for coordinating a lot of this. So one of the things that we landed this last few months is applicative recursion, and this is the ability to take zero-knowledge proofs and recurse them to compress the state temporally, and allows you this property of having essentially like abundant state inside of the execution shard that then can be compressed into something much smaller and settled on chain, like significantly reducing data availability costs of posting this computation on chain. The concurrent execution shards is something that we're developing. Basically, like right now when you spawn an execution shard, you hold a lock on the underlying state on the chain, and we're working on introducing like some ideas like similar to the topology work on CRDTs, where you can have different types that have commutative properties that don't need to hold a lock across them. And so basically modifying the way that ZK rollups today like settled in a very declarative way. They just say like, hey, the value of this storage slot is now, like storage slot Y is now X. In this case, it's just like modifying the state diff implementation to be imperative operations, to say instead of like, this balance is now 10, to say like increase the balance by 1. So that's something that we're working on integrating into like a modification of the StarkNet OS to support concurrent execution shards. And then just integration in the modular ecosystem. We want Dojo to be able to interoperate with a bunch of different services, so developers can kind of pick the thing that makes the most sense for the affordances that they want with their game. So on the proving side, there's a few different proving providers. There's Stone, which you can operate by yourself. There's Sharp, which is like the infrastructure that Starkware operates. There's Gibalot, and there's like a few other proving as a service providers coming in that you can just say like, okay, we want you to prove our computations, and you just go to, essentially it's a commoditized service. You just find the cheapest one and ask them to prove it. Data availability, something similar. Like we have StarkNet and Ethereum integrated today, and Celestia as well. We'll probably add EigenDA and Avail if people are interested in that. And then verification, so actually verifying the proof, settling to them to different chains. We support StarkNet today. We'll add Ethereum and some of the other like verification layers that are starting to come in, like Aligned and Nebra and Heil are some of the interesting ones. SDKs, we have a team building SDKs for the Dojo toolchain. So We want basically people to write smart contracts or the models and the state and the logic of their world and be able to consume it immediately inside of the clients that they're building. So everything in between is taken care of for them. And so we have like a tool chain for developing, for generating typed SDKs that allow you to have like reactive state bindings that are fully typed to your state on chain. And we're doing, have a few different efforts in that regard. Our approach is basically to have like a canonical Rust implementation of the SDK that we then generate bindings for. So we have C bindings for it, C# bindings, we have WASM version of it, and we can implement logic once, and all of the SDKs inherit this. Today we have Unity, we have the communities working on Bevy and Godot, and there's been some interest in working on Unreal, so if those are any of those are interesting to you, we're eager to support efforts to add these SDKs to the tool chain. It's actually relatively easy, it's mostly just defining some type bindings. Controller support, so any games that are using the SDKs should have native support for session tokens and using controller, which uses WebAuthn and allows you to just provision keys for your players using the secure enclave in a non-custodial way with like very little friction. So we have controller support inside of the SDKs that makes it easy, even in native games like Unity games. The new TypeScript SDK, that's going to be a significant improvement there. And then optimistic updates is the next piece that we're working on, which is basically executing the Cairo VM directly in the browser, so you can do things like fee estimation and reduced latency for transactions that you're submitting on chain, but also in the future do client-side proving very easily with the client-side execution. And then Slot. So Slot is the execution layer that we've developed at Cartridge that enables a lot of these technologies to be productionalized. So the Dojo toolchain is something that you can use locally for development. You can spin up all these things, and then we have Slot, which is a productionalization of it, and provides like these low latency, high throughput, dedicated execution environments. A lot of people in the ecosystem today are using them for play testing, and we're working towards productionalizing it this year. We've had 165 deployments on it and close to 1.25 million transactions executed through it. We also have like native controller support on Slot now. So if you spin up a Slot Katana instance, all your players will have their accounts already there. They don't have to like onboard a new wallet. They don't have to worry about switching networks. They don't have to worry about faucets and stuff. You just can play. So you have this unified experience for players. We're working on the settlement component of it, actually productionalizing that, like posting the proofs. We have this working end to end. It's just not in production yet, of generating the proofs of some execution with Katana on Slot, and then posting that proof to StarkNet and updating the underlying world's state. And then decentralization, we're looking at different approaches to decentralizing the operation of Slot so that anyone can basically operate these execution shards in the ecosystem. Right now, and Cartridge will just be a provider of that rather than like the provider of that. I think that we'll have some more exciting developments on that probably in the first half of next year, a little bit more concrete of a roadmap of what that would look like. Controller, I mentioned it a few times in here. It's basically our account that we've developed for the Dojo ecosystem with the goal of enabling just frictionless onboarding of players to these different technologies, something that's not provided by any of the solutions that we've had access to so far, that works cross-platform across like all these different modalities and SDKs and native applications. We originally built Controller and released it about 1.5 years ago, and then we just like decided to put it on the back burner and focus on the Dojo and stimulating the development of games in the ecosystem. Now we've seen so many games start to ship to production, so we've basically reprioritized Controller. We haven't really even announced it, but a bunch of games have started integrating it, and players are playing with it already. It's been live for about 10 days, and we have like 10 different integrations and 800 people working on using it to play these games, and we have native paymaster support inside of it as well, and we've executed over 15,000 transactions with it just in the last few days. And this is what it looks like for games. It's basically a white labeled version of a controller implementation that looks very similar to what players expect from traditional experiences. You just enter a username, log in or sign up. There's a Face ID to issue your credentials, creates a session token that is a bearer token with some scopes that are authorizes the application to execute on your behalf, and they can start playing the game, and you can be confident that they're not like, sending all your NFTs to an AMM or something, that they're only executing the transactions that are within the scopes that you provided them. So some of the stuff I mentioned there, Web Authentication Tokens, that is ready. Paymaster support is also ready. That's means that we can just subsidize transactions. What that looks like in testing is that you never have to worry about testnet ETH anywhere that you had traditionally. Like if you had a game deployed on Sepolia or something, you'd have to go find a faucet, get some ETH to be able to play it. We just have a ton of Sepolia ETH, and we'll just fund all your transactions and interactions with these games, so people can very easily play test them. They don't have to worry about that friction. And then we can do something similar in production. We can choose to subsidize transactions for users. And in the context of slot and execution shards and Starknet, where fees are so low, it's practically possible to start to subsidize these things. Like the execution of an entire game can cost 10 cents or 20 cents. And from a user acquisition strategy perspective, it potentially makes sense to make that investment to let people just play your game and then convert them and capture value or recoup that somewhere later. And then identity and reputation is what we're building into the controller next. It's the same idea as having this unified controller that always exists anywhere Dojo games are, and having your shared identity across all of them. We're introducing some ideas around on-chain quests and achievements that can be accrued to the identity of these players. And then we have some ideas of how we can use that to essentially stimulate participation in the ecosystem and try and further compress the development loop of getting people to come and check out games, provide feedback for them, and try and iterate just more rapidly to figure out what are the interesting things that people are excited about that we can build with this modality. So that's it for the update on Dojo. I'm happy to answer any questions if anyone has, or hope that was interesting for you all. Cool.
Loads going on.
Yeah, I know it's a lot of information.
But yeah, good stuff. You mentioned it's planned to have verifiability on Tori to make it possible to make sovereign roll-ups.
Mm-hmm.
What's missing currently means you can't do that already, since it's all provable. You've got the say it working, it's all not already a sovereign roll-up.
Well, you can do it already, but it's not easy for anyone to do it.
Okay.
Yeah, so the goal is that this stuff is just super easy to do, right? You don't want players to even think about it. You just want them to have confidence in it. So yeah, we have in the sovereign rollup context, we have today posting proofs and state diffs to Celestia, and then Tori can pull those and verify those proofs. All of these pieces exist, they just haven't been put into a coherent kind of implementation.
So you want it in the hands of the players, not the developers, so the players can choose to play as a sovereign rollup as opposed to something that's settling on.
Yeah, so it can be anyone can run a Tori instance. I think it's light enough because you don't have to do re-execution. You're just doing proof verification. It's very cheap to verify the current state, so you can embed it in any client, in the web client, for example. You can't do that with a regular blockchain node. It's just the execution component of it is obviously too expensive. So ideally, everyone can just very cheaply verify the current state of the world. And then the sovereign roll-up architecture is I think particularly interesting for games because the meta can diverge into two different parallel strands, right? If you, especially for game developers that aren't necessarily interested in the financialization component of blockchains, a sovereign rollup provides you some isolation from that, and allows you still to have a lot of these properties on the hardness of the world that you're building and the ability of players to kind of define what is the meta, and potentially govern the underlying worlds. Cool. Awesome. Well, thank you all.